Hi, my name is Gordon France, your EdTech nomad, recording for Lenira. So we run a series of test recording in a new blog series about to start, and this is the first one of it. So I would like to see and hear from you what you think about this recording as we progress and churn out more of these such series that we'll be running. So basically this channel is geared towards simulations and talk about science, to show students how to use basic tools out there, from artificial intelligence to electronics to chemistry, which is not my area of specialty anyway, and to earth science and a bit of mathematics, anything in relation to STEM education. So STEM stands for science, technology, engineering, mathematics. So anything related to this area is what we at Lenira we strive to make sure that the best tools available in this field are made accessible to every kids out there, making quality education accessible to everybody. So today, briefly, we're going to look at projectile motion, and I'm going to be launching a car over a distance. Okay, so we're going to look at a bit of space travel, a bit of some postulations from about 120 years ago, and to see how far we've come with these postulations. So first of all, let's take a look at this. So our first test subject, or a scientist, a school teacher actually, in the 20th century, in 1898 actually, who goes by the name Konstantin Chovolsky. To my Russian friends out there, I hope I got the name pronunciation right. Konstantin Chovolsky postulated and made his publication available, named Exploration of the Universe with Rocket-Propelled Vehicles. And I think Elon Musk is a crazy guy actually. I think Elon Musk took this publication a little bit too literal. I mean, over the years, NASA, the American Space Agency, has done a fantastic job with space exploration by launching lunar missions and sending man to moon and orbiting the Earth. The Russians also, the Russian cosmonauts have also been to space, orbited the Earth many times, and we now have the International Space Station that houses astronauts or spacemen from many countries. But we're going to look at Elon Musk temporarily and what he did with this publication, and also Konstantin Chovolsky, I probably didn't mention this, is father of modern astronautics. So a lot of things that has to do with space travel, Konstantin touched it. But the problem over the years with what NASA has been doing is that rockets and space travel and the rocket-propelled vehicles were not reusable. So this had to cost American taxpayers millions of dollars. But Elon Musk, once again, I said, a fantastic guy with his Falcon X space rocket, has made rocket-propelled vehicles reusable. So in 2018, as I mentioned earlier, Elon Musk took the literal term of Konstantin's publication of launching rocket-propelled vehicles into space by launching the Tesla Roadster into space. I'd say that there was a major news about SpaceX, and but actually what it's all about was the reusable rockets. Unlike previous years when NASA bans out these rocket-propelled vehicles and not be able to reuse them, causing and pushing space travel costs a little bit higher. And with Elon Musk's revolutionized space travel model, we're going to be able to send man into orbit and bring him back without burning out the rocket. So let's say you want to explain these concepts to a high schooler or a junior high schooler, or maybe your kid at home, your high school, your primary school kid. This where the FET comes into action. So the simulator helps you to simulate scientific laboratory environment. And so I was thinking about it, and I was like, hey, if Elon Musk has been able to send a vehicle that's a Tesla Roadster, why can't I simulate same thing by giving them a visuals and something to play with and a controlled environment to run the experiments themselves and have a feel of what it is. So we believe we are excited at Lenira and we believe this will help students become much more creative and imaginative in their approach towards STEM education. So this is our PhET interactive simulator, and what we do at Lenira, we help in distributing this simulator. We train and teach teachers how to use it, and today we're going to explore what the Tesla Roadster is going to look like, projecting a Tesla Roadster, actually not an exact replica, but something similar through a cannon. Yeah, so we have a cannon, and we have a gentleman over there in his boxer shorts, and we can control the height of the cannonball. Where the cannonball sits, we can vary the height as we want. So we're going to leave it at 9 meters. So what are we going to be launching out of the cannonball? We also can manipulate the angles, so just like space rocket travel, in space exploration, the rocket propelled vehicle has to hit or leave the Earth atmosphere at a particular angle and with a particular escape velocity before it can escape the Earth's atmosphere and move into orbit. So that's what Elon Musk did. But this time around, we're just going to project our vehicle over a distance horizontally, over an horizontal distance. And so this bull's eye down here kind of help you to project where the vehicle is going to land. So maybe the mass of what we're going to be launching, I'm not going to be using a pumpkin. So if you look at the top right corner of the simulator, we have a pumpkin. I'm not going to use a pumpkin. So we have other objects we can launch through the cannonball or the cannon launcher, and I'm just going to go straight down to car. So I'm going to be launching a car. So the weight or the mass of the car has been set to 2,000 kilogram, and the diameter of it is 2 meters. I'm going to leave the air resistance the way it is, and we're going to play around and see what it's going to look like. And so let's project our car at an angle of let's say 45 meters or 45 degrees actually, sorry, 45 degrees, set 9 meters height, and I'm estimating that it's going to land at 24.3 meters with an initial speed of 15 meters per second. So these are some of the variables that you could play with, a child got to play with and see, or you could gamify the learning process. Gamification means turning learning into a game. So you gamified the teaching process. So let's launch this. So this is my launcher, the red button over here. That's the red one. So maybe I could have written a countdown, maybe in Python, a countdown program that does the same thing that NASA does. Maybe a countdown from 5. So 5, 4, 3, 2, 1. Then fire. So I missed it. So here we've been able to propel a car over a distance of, let's now find the actual distance. So the car was launched, the car landed at 30.1 meters. So the variables, once again, these are some of the things you can allow the kids to play with and have fun while learning. Yeah, welcome back. Welcome back to my main screen, and I hope you've learned it. So we teach educators and sometimes directly to the students how to use these tools, and I hope yourself you've learned about space travel, about Elon Musk and the Tesla, and about NASA, and I hope you've learned about rocket propelled travel from the initial postulation from 120 years ago to where we are right now, and Elon Musk literally taking the term vehicle to another height. I'm your EdTech nomad, and this is the Lenira series we'll be running, and this is my test run. Thank you. I would like some feedback from you. Let me know. I'm still testing all the variables of recording, yeah? So a lot of things are going to change as we move along, and thank you for your time. Bye-bye.